Welcome back. This section will be about replication and switchovers. In this section, we are going to take a brief look at advanced replication features like parallel and semi-synchronous replication. We will also learn how to check replication consistency, and we will talk about how to promote slave to master. Let's start with the last one, switchovers, or promoting a slave to master. In this video, we are going to take a look at how to perform a switchover manually. After that, we will learn about how it's typically done in a production systems using tools. Last, we will take a more detailed look at one of the tools, and that will be Orchestrator. Replication topology management can be done with the change master SQL statement. We already did this a couple of times. With GTID replication, repointing machines in a topology is easy. With file name and position based, it's somewhat harder because binary log positions have to be maintained during the operation. Switchovers are usually managed by some external tool. MMM is probably one of the oldest ones. It's not developed anymore and it's not recommended to use. Probably because it was the first of its kind, it's not rare to hear people doing these kinds of operations as doing an MMM. MHA is very similar to MMM but architecturally better and well tested. It is still quite popular, but its pace of development has slowed down already. The MySQL RPL admin client utility is part of the MySQL distribution by Oracle. It's a tool to provide graceful failovers, to handle the situation when a machine needs to be promoted when the former master is still available. The MySQL failover client utility is also part of MySQL distribution by Oracle. It's a tool to handle the promotion when the former master is unavailable. For example, it crashed or when it is isolated from the rest of the cluster from the networking perspective. Orchestrator is the state-of-the-art tool for MySQL topology management. It was developed by Shlomi Noach. It's quite mature and has many production deployments at a large scale. On this slide, we can see the web UI of Orchestrator from the lab where we will try it out. It is capable of relocating slaves both in case of GTID and non-GTID replication. For non-GTID replication, it achieves it with using pseudo-GTIDs by injecting its own transaction identifiers. With the new auto-pseudo-GTID feature in Orchestrator, these identifiers can be injected seamlessly from Orchestrator itself. It can do graceful promotion, promote a slave to a master while the original master is still alive. It can recover a cluster from dead master on dead intermediate master situation. Intermediate master meaning a slave which also have slaves. It has a nice GUI, but what's more important, it also has a nice API. So all the switchovers, relocations, every operation can be done programmatically as well. It is capable of using Raft and making decisions based on group communication consensus. This is very important for automatic failover. Or with other words, automatic replacement of unreachable or isolated masters. Let's do Lab 7a together, where we will try switchovers with Orchestrator. Please note that we are just scratching the surface here. Orchestrator has an excellent tutorial at conferences. This is just enough to get started and start to play with it. Welcome to the lab about switchovers. First, let's check if our virtual machines are running. We have 4 machines here, so I will be using 4 tabs. Let's start the environment. We will have the Orchestrator node and the 3 database nodes it will manage. The environment is booted up. For you, very likely it will be somewhat slower because of video editing. Let's log into each box, the Orchestrator and all the database boxes. So I will first log into the Orchestrator box. And go to the next tab, log into the first database box. Then go to the next tab, log into the second database box. Then go to the next tab and log into the third database box. Okay, we are all logged in. So now on the master, we will start the MySQL client. So master is DB1 right now. And we are creating a database called meta, and we will just insert the cluster name into it. This will be used by Orchestrator. We will tell Orchestrator to use this table to figure out the cluster name, and we will grant the Orchestrator user access to this metadata database. So first, let's create the database and set the default schema. So it's done. Then we can create the table and insert a single value into it, which is test cluster. Now that's done as well. And grant access to the Orchestrator user. This is done too. So now we will work on the Orchestrator node and install the packages. We have the packages in the Vagrant user's home. We can use yum local install. The Orchestrator package is the daemon. The CLI is the command line interface that we are going to use. We will copy the sample configuration to its final destination. So let's just do that. And next we will open the configuration with an editor and change the MySQL username and password to the Orchestrator user we have on the system. The Orchestrator user was already created as part of the setup process by the automation. And the username and password is orc and orc. But this will be both the user for Orchestrator's database on Orchestrator's node and both the user which it will log in to the topologies. Like in production, very likely you want to use different users for this, but for now, for the purposes of this demonstration, it's fine. So let's edit the configuration file. And we want to change the MySQL topology user here and the MySQL topology password here. And we also want to change the MySQL Orchestrator user. So the previous one we changed was the user Orchestrator uses to log into the MySQL servers. Now we are changing the password the Orchestrator uses to log into its own metadata database. So we change the passwords. Good. And we have one more thing. The detect cluster alias query, we will supply a custom query for that. So we search for detect cluster alias query. So see, by default it's based on hostname. And we want to change that to, and now it will work. Okay, cool. If we are finished with the configuration file. Now we want to start a MySQL client on the Orchestrator itself and set up its metadata database. First, we will create its database. So we will use a MySQL client and do create database Orchestrator. We grant the orc user privileges to this database and exit the MySQL client and start the Orchestrator service. Done. Let's wait a bit. Yeah, we waited a bit with this and check its log. Seems okay. And if we point the web browser to 172.17.17.14:3000, then we will have access to Orchestrator's web interface. What we are going to do is register a cluster on Orchestrator. We will provide the entry point to the master, and Orchestrator will just discover its topology. So we issue the discover command, Orchestrator discovered the cluster. And here, if I refresh this page, test cluster appears right there as we specified in the table. It has that name. And we have a nice visualization of the topology of the cluster. Now what we can do from here, for example, I can do that, and that will relocate that slave to... So I can put it back via the command line. Sometimes, or I cannot drag and drop. We can query the clusters from the command line. And we want to run the command topology on cluster. See, lab 78db2 is now under db3. And I want to relocate this to lab 78db1. Relocate is done, and if I query the topology again, it's there. And if I go back to the web interface, they are right there. So in order to make one of these the master, I need to make it the only slave. So I will relocate this to here via the browser. And now I will drag this and drag it further than the box until it says promote as master. So I click OK to promote it as master. And now I will have lab 78db2 as master, but it will have a problem not replicating. And lab 78db will also have replication issues. Let's see that the former master, lab 78db1, is not replicating, but its new master is lab 78db2 as we intended it right here. So I'm just gonna start the slave, and we should be okay with that. On the new master, on the other hand, a replication thread is still configured pointing to the old master. I want to reset that slave, so I want to unconfigure that. We have a warning. And if I refresh this page, now I have the topology changed, and db2 is the new master. Usually, if you want this kind of graceful promotion, you can have a wrapper around it or something. Usually, Orchestrator is not the only tool. What is needed for an actual production master failover, for example, if you are using virtual IPs to manage the entry points of your cluster, you need to specify Orchestrator hooks to manage the virtual IPs. Orchestrator itself can publish the master servers of each cluster in console, but if you are using other service discovery, you might want to use hooks as well. So this is a component, but definitely not the whole picture. You know, I can keep moving slaves back and forth, and it will still work. Okay, that's it. We can verify the topology here. Even we can log into db2, and we can use pt slave find, and let's view localhost, and report type we want hostname. Report format. Yeah, so we can see it here that the topology indeed changed. Alright, that's it. Congratulations for setting up Orchestrator for the first time if you did this the first time. Otherwise, this serves as an introduction. Orchestrator has much more features and it's much more deep than this, but this should be enough to get going with exploring it. One more note for the lab, don't forget to destroy your infrastructure, but probably you've got used to this by this time.